percents, increase and decrease, part 2. Okay, in part 1 of this set of videos, we found the increase or decrease by first finding the dollar amount or the unit amount of change, and then finding the new result by adding or subtracting that new amount. In this video, we're going to find the new amount in the increase or decrease differently. We're going to find it directly, okay? And the way we're going to do that, just another way of doing the same thing, is that we're going to, and again, we're still in percent increase or decrease problems, but we're going to find the new amount directly by adding or subtracting the percents first. Then we'll multiply this new rate by the original or the beginning amount. Okay, so this time we're gonna work with the percents first, and then we're going to do the multiplication after that. Okay, so we're going to add or subtract percents and then do multiplication, whereas in part 1 we did multiplication with the percent and then we added or subtracted the amounts. Okay, what we need to remember and we need to know for this is the percent for the original or the beginning amount is always 100%. We're going to make use of that. Okay, so to find the new amount directly in a percent problem, we first want to find the rate of the new amount. Okay, if it's an increase, then that rate is going to be 100% plus the percent increase. If it's a percent decrease, then the new rate is going to be 100% minus the percent decrease. So we've done the math with the percent here by adding or subtracting the percent first, and then it's simply the new amount is equal to the rate of the new amount, what comes out of step 1. I'll tell you what, I'll put that in here. This is from step 1 times the original amount. All right, a fair amount there. Let's take a look at some examples. I think it'll help it make a lot more sense. Okay, I've already written these up. I've turned the page to have a bit more space. Okay, a product that costs $45 is marked up 25%. So we have a percent increase of 25% because it's marked up. Find the new cost directly. Okay, so we first need, we'll come back to here. We first want to find the rate of the new amount, and this is an increase. So we're going to add the percent to 100. Okay, so I'm going to write all this down so we can see it. So the rate of the new amount is equal to 100%. And again, we're marking up, so we're going to add, we're going to add the percent increase because we marked it up. And of course, that means our percent increase is 25%. So we're going to add 25%, and our rate for our new amount is 125%. Okay, so now let's go. So we know what our new rate is. The new amount is going to be 125% of the original amount. Okay, so we go back here and we look at step 2, and step 2 says our new amount, how to find it directly, is take this rate, which we found was 125%, and multiply it by the original amount. Okay, let's make sure you can see my page here. So we're going to say that our new amount, and again, I'll write it all down, equals our new amount is our rate of new amount, which is right here, times our original amount. Okay, our new amount, well, the rate of our new amount is 125% times our original amount. Well, the original amount was marked up from $45. That's where it started, times $45. Okay, we need to remember that when we do math with percents, we need to change them to their decimal form. And so we've seen in previous videos, we replace the percent sign with the denominator of 100, and then we divide. So 125 divided by 100, and we know that results in moving the decimal 2 places to the left. So the rate is 1.25. We'll also recall that this rate is above 100, so we have a whole number in front of the decimal because it's larger than 1. And we're going to multiply this by 45, and I'm going to take out my calculator and do 1.25 times 45, and I come up with 56.25, which of course in our problem, the new cost translates as dollars. We don't have to worry about rounding decimals because we're already in 2 decimals, hundredth of a dollar or cents. And the new cost is $56.25. So we've just done that directly. Okay, what directly means here is we first found the new percentage. Well, if we're going to mark it up 25%, the new percentage is 125% of the original price. Okay, here's 125%. We know that of usually means multiplication. 125% of $45, 1.25 times 45. The new amount is $56.25. So it got marked up. It certainly should be higher than the original price. Let's do a decrease problem. Then I'm going to do a kind of a combo problem that you may see. Okay, we got a pair of jeans. They originally cost $49.99, and we're going to mark them 70% off. They must be either going out of business, or maybe maybe it's a pair they've changed the look of the jeans for 70% off. What's the sale price? Okay, well, let's first take a look at the rate of the new amount. Okay, the new pair of jeans is 100% minus the percent decrease. Okay, these are 70% off. That's a percent decrease if they've gone down by 70%. So we're going to start with our base price, our base percentage, base price, 100%, and we're going to subtract 70%. And we're going to come up that our new cost for the jeans is going to be 30% of the original. This is the rate of our new amount is 30% of the original amount. Okay, so we know that our new amount in dollars, in this case I'll put the dollar sign here to help us, is equal to the rate of the new amount times the original amount. Okay, well the rate of our new amount is 30%. Okay, 30% times the original amount. The original amount was $49.99. Okay, we know that when we're working with percents, again, we want to factor in that 100 and change it to a decimal. So the percent sign becomes a 100 denominator. 30 divided by 100 is the same as moving the decimal 2 places to the left. So I wind up with 0.30 times $49.99. And let's see what this comes up to. Again, I'll pull up my calculator and I will do the math here. So 0.30 times $49.99, and I come up with 14.997. Okay, well this is money, so we know we need to round to the nearest cent or the nearest 100th of a dollar. So I'm going to look to the right. The 7 pushes the 9, well, it pushes it all. Pushes the 9 to a 10, which pushes this 9 to a 10, which pushes this to 15. So this is equal to $15 is the sale price of the jeans. The sale price of the jeans is 30% of the original cost of the jeans. So we did the percent math first, and then we applied that new percent, 30, into our multiplication problem down here. Okay, let's look at one more problem that'll apply both of these things. Okay, this takes place in a lot of your industrial or your engineering, your construction situations. It's very difficult. Getting perfection is next to impossible. So there's almost always an allowance for things to be slightly off when you're creating a part. So in this case, I'll start the second sentence. We want the part to be 57 centimeters long. Okay? But getting it exactly 57 and doing that over and over again, it can be slightly off when things are cut. So what normally takes place is you allow for a slight error and you say that that's close enough. So in this case, we're going to allow for a 3% error for a machine part. And we can still use it if it's off by 3% in either direction, a little bit too long, a little bit too short. The part is still usable. It doesn't have to be exactly 57. It needs to be between a couple of lengths so that it's very, very close to 57, and then we can still use it. And the question is, what is the range of measures that is acceptable? Okay, well, let's take a look. We know that this is, basically what we're saying here is this part's length can be 57 centimeters plus or minus 3%. We can have a decrease of 3%, or we can have an increase of 3%. As long as it's within that range, we will say the part is acceptable and we can use it. Okay, so let's take a look first. Range. So let's take a look first at the smallest or the shortest. The shortest length that is acceptable. Okay, I'll put an A there. Shortest length that is acceptable. Okay, well, we'll go back to what we saw before. Okay, we're going to deal with a decrease. We're going to subtract, and we saw that we want the rate is the 100% minus the percent decrease. Okay, the rate for the new amount. So the new rate, for the new length is going to be, for 57, that's the whole, so it's going to be 100. 100% is what stands for, is the length of the, it's the length of the part itself, okay? The beginning amount, 57. So it's going to be 100% minus 3%. So we're going to allow the shortest length to be 97% of the original. Okay, so the new length, and we know this is shortest acceptable. Let's see if I can spell acceptable. Is equal to 97% of the original 57 centimeters. Okay, and again, we know that 97% as a decimal. We drop the percent sign, write it as with a 100 denominator, dividing by 100, remove the decimal 2 places left, and we have 0.97 times 57, and I'm going to pull out my calculator. 0.97 times 57, and I have 55.29 55.29 centimeters. So the shortest length that's acceptable is 55 and 29 hundredths of a centimeter. As long as it's this length or longer, we'll accept it. This is as short as it can be in order for us to accept it and therefore use it. Okay, now let's take a look at the longest length that is acceptable. Let me get my sheet up a little bit here. Longest acceptable length. Okay. First things first, the rate for the new length, in this case it's the longest one, well, it's going to be 100% plus 3%. So up here, we were subtracting 3% to get the length, the rate for our the shortest length, the new length for the shortest. Here we're going to add 3%, and we know that's 103%. This part can be 103% of the base of what we're looking for, of the original length that we're looking for. Okay, so the new length, and again, this is the longest acceptable, is equal to 103% of the base, which is 57 centimeters. We can be a little bit longer than 57 centimeters. And we know again that 103% is greater than 100%, so we're going to have a whole number in front of the decimal. And we know this is going to be 1.03. 103% as a decimal is 1.03 times 57. And again, I'm going to take out my calculator and do that math with my calculator. And I come up with 58.71 centimeters. Okay, which is slightly longer than 57 centimeters. Okay, this is the longest acceptable. Okay, so the question up here says, let me get back to the question, you can see it. What is the range that is acceptable? Well, we'll accept, okay, we'll accept a part that is from 55.29 centimeters to 58.71 centimeters long. Okay, that gives us our range. Obviously 57 is right in the middle here. As long as it's between these two, the part, we can use it, it's acceptable, and we can do something with it. So there you have, how can you find a new amount in an increase or decrease, in a percent increase or decrease problem directly?